Have you ever stood in front of your fridge at 11:47 p.m., telling yourself it's just a small snack? But what actually happens inside your body when you eat late at night? Is it automatically stored as fat? Does it really slow your metabolism? Or is that just another diet myth? Let's break it down using neuroscience, endocrinology, and metabolic physiology.
Welcome to SciCuriousID, where curiosity meets science.
Your body runs on a 24-hour internal timing system known as the circadian rhythm. This clock is regulated by a small region in your brain called the suprachiasmatic nucleus, located in the hypothalamus. It synchronizes sleep, hormone release, body temperature, and importantly, metabolism. During daylight hours, your body is biologically prepared to process food. Insulin sensitivity is higher. Glucose tolerance is better. Your muscles and liver are more efficient at taking in sugar from your bloodstream. But at night, things shift. Melatonin begins to rise in the evening. While melatonin prepares your brain for sleep, it also affects the pancreas. Research shows that melatonin can reduce insulin secretion. That means if you eat a carbohydrate-heavy meal late at night, your body may not handle glucose as efficiently as it would earlier in the day. Several controlled laboratory studies, including research published in Cell Metabolism, demonstrate that identical meals consumed late at night produce higher and more prolonged blood glucose levels compared to the same meals eaten earlier. In simple terms, your body is less metabolically flexible at night. Now let's talk about energy expenditure. Metabolism doesn't shut off at night. That's a myth. You continue to burn calories while sleeping. In fact, your brain alone uses significant energy during REM sleep. However, research suggests that late eaters may burn slightly fewer calories overall and show hormonal shifts that increase hunger the following day. One study found that late meal timing was associated with decreased levels of leptin, the hormone that signals fullness and increased hunger perception. This doesn't mean one late snack causes weight gain. Weight gain fundamentally depends on long-term energy balance, calories consumed versus calories expended. But late eating may subtly influence appetite regulation, glucose control, and food choices the next day. When you eat late, especially large meals high in fat, several physiological changes occur. Your body temperature increases. Digestion activates the autonomic nervous system. Gastric acid production rises. If you lie down shortly after eating, this can increase the likelihood of acid reflux. Even mild reflux can fragment sleep architecture, reducing slow-wave sleep and REM sleep. Poor sleep then affects insulin sensitivity the next day. Even one night of reduced sleep has been shown to impair glucose metabolism. So we see a loop forming: late eating disrupted sleep, impaired metabolic control, increased hunger, higher calorie intake. If you work night shifts, your circadian rhythm may adapt partially to your schedule. If you train late in the evening, a small protein-based meal may actually support muscle repair. And if your total daily calorie intake is balanced, occasional late eating is unlikely to cause harm. The issue isn't simply time. It's biological alignment. Chrononutrition, the science of meal timing, suggests that aligning food intake with your circadian rhythm supports better metabolic outcomes. From an evidence-based perspective, here's what seems most consistent. Eating earlier in the day improves glucose tolerance. Stopping food intake 2 to 3 hours before sleep may improve sleep quality. Smaller, protein-focused late snacks are metabolically safer than large refined carbohydrate meals. But biology is not morality. Late-night eating is not a failure. It's a physiological event with measurable effects, not a character flaw. The key question is not, is eating at night bad? The better question is your eating schedule aligned with your body's biological clock? Because your metabolism is not just about what you eat, it's about when your brain expects you to eat. Now I'm curious, do you notice differences in your sleep or hunger levels when you eat late? Or have you tested shifting your last meal earlier and felt any measurable change?
Thanks for watching SciCuriousID. Until next time.